Hi all. In this video, we will discuss about different logic families that is included in the second module of the KTU syllabus, that is Digital Electronics and Logic Design. And all ICs are fabricated using various technologies. That is, some ICs using transistors inside that, and some are using MOSFETs inside that. So based on that, we are classifying these logic families into different types. Okay, so in this video we will discuss about the basic specifications of the logic families and what are the different types of logic families we are normally using. That is, we have to learn in our subject. Okay, so the first specification terminology is the propagation delay of the gates. We have already learned different gates and gate or gate like that. So the propagation delay of a gate means we know that a pulse through a gate takes a certain amount of time to propagate from input to output. That is, there is a time delay in between we are applying an input and we are getting an output. Okay, so that time delay is called the propagation delay. Okay, so the propagation delay will be different for different logic families. Okay, and the next specification is the power dissipation. And the power required by the gate to operate with 50% duty cycle at a specified frequency and is expressed in milliwatts. So this is the power dissipation for a gate. That is, we know that power dissipation is mainly depending upon the current drawing. Okay, current drawn from supply. We know that for different gates, the current drawn in high state is different from that drawn in low state. Okay, so there will be a current difference between the high to low states. Okay, so the power dissipation means it is the power required by the gate to operate with 50% duty cycle at a specific frequency. Okay, that is 50% duty cycle means that is 1 and 0 periods. Okay, that is, we know that the output of a gate is either 1 or 0. Okay, that is 1 and 0 periods of the output are equal. Okay, so we are considering that condition. Okay, so that is the power dissipation of every gate. And the next one is the Fanin and Fanout. The Fanin is the number of inputs that the gate is designed to handle. Okay, how many inputs we can connect to a single gate. Okay, so that is denoted as fan in. And next one is fan out. Fan out means it is the maximum number of standard loads that the output of the gate can drive without impairing its normal operation, means without affecting its normal operation. Therefore, the fan out is also called as the loading factor of the gate. Okay, and this fan out maybe that is two types of fan outs are there. That is, high state fan out is there and low state fan out is there. High state fan out means it is the fan out of the gate when its output is a logic 1. Okay, that is high state fan out. That is when the output is logic 1. At that time, how many number of loads we can connect to the output of a gate. That is the high state fan out. Okay, and low state fan out means it is the number of loads we can connect to the output of a gate when the output is at low. That is, output is at a logic 0 value. That is low state fan out. Okay, so two fan outs are the high state fan out and low state fan out. And for a given gate, we will determine the high state fan out and low state fan out of a gate, and we are taking the smallest number among that two. Okay, the smaller of these two numbers is taken as the actual fan out of a given gate. Okay, so that's about a fan and fan out. And the most commonly used logic families are the CMOS and TTL. CMOS means it is the short form of complementary metal oxide semiconductor logic. Complementary metal oxide semiconductor logic. And TTL means transistor logic. So in the first logic family we are using MOSFETs, that is N channel or P channel MOSFETs inside the ICs for constructing different gates. And in the second family we are normally using N channel and P channel transistors, bipolar transistors, BJTs inside the ICs for constructing different gates. Okay, so as a simple comparison of different logic families we are using is given in the table here. So here in that among that TTL and CMOS we have to learn. Okay, so the propagation delay time, it is given in nanoseconds. So for a TTL family the propagation delay is 9 nanosecond, but for CMOS it is less than 50 nanosecond, little more higher than TTL. Okay, and the power dissipation is 10 milliwatt for TTL, normally a TTL gate, but it is very less, 0.01 milliwatt for a CMOS family. Okay, it is very less. And the noise margin is 0.4, and for CMOS it is 5. And Fanin is, noise margin is nothing but the noise immunity. Okay, and the fan in is for a TTL it is 8. Okay, 8 inputs. Okay, 8 loads, 8 device can be connected to the input of a gate, but for CMOS it is 10. And fan out, that for TTL it is 10, but CMOS it is 50. Okay, larger than TTL. Okay, and the cost is low for both the families. Okay, so this is the comparison of TTL and CMOS families. I hope all of you understand the basics of the logic families, of these two logic families.